This video is to be able to make your test corrections for this last test, Unit 1B, Food Web, Food Chains, Energy Pyramid. You need one of these forms. Remember, we did this for our last test, where you need to fill in the question that you missed, your answer, the correct answer, what did you misunderstand, what was it that you read from the question, where it made you go wrong, where it made you make the wrong, pick the wrong choice. Then it says key or troublesome vocabulary. This is where you type in the vocab, the words, the terms, the science word that you did not know, and then so you just make a list right there. So make sure if you don't have one of these, you can make one with just normal notebook paper and just fill it out like this. Okay. Alright, so let's start with the test. Question number 1. It says, what kind of energy is necessary to initiate the process of photosynthesis? So first of all, I'm going to circle some keywords. Energy. So we're looking for a type of energy. Initiate. Okay, if you don't know what the word initiate means, it means to start the process of photosynthesis. And we know that photosynthesis is trying to make food for plants. Okay? Food for plants. So what kind of energy starts this process? Alright? Radiant. Radiant's the one that comes from the sun. Alright? Heat, we don't know the source. Source. Electrical, don't know the source either. And wind, that has to be something about the weather. Okay, if we remember our equation for photosynthesis, we need to be able to have water plus carbon dioxide. Mix that or put that together in the plant, in the leaf, in the chloroplast with the radiant energy, and that gives us glucose and oxygen. Okay, if we don't have radiant energy, then we can't have this process happen. So our best choice is going to be A. Alright, let us move forward. Number 2, during the process of photosynthesis, again, circle the word photosynthesis if you haven't. It's food for plants, specifically glucose. So now we've got to find something that's happening during the process. Light energy, okay, we're good so far, is converted into chemical energy. Alright, this one makes sense. True, the light's coming from the sun, and it's converted into glucose, which is a chemical. So far I'm going to question mark this one. Chemical energy is transformed to mechanical. Chemical energy is not starting from the sun, so it can't be that one. Thermal energy, which is coming from the sun, is changed to chemical energy. Thermal energy doesn't help the plant. Okay? The plant needs light. Okay? So no. Then it says solar energy, okay, maybe. We're going to say yes, because it is technically energy from the sun, and it's converted to mechanical energy, something that moves. And this part is not true. So J cannot be your answer. F is your best choice. Alright? If you didn't know what mechanical energy is, look it up. But it's not anything that we've learned in class. We should have learned this in 5th grade, and that has to do mechanical, with moving things, with moving parts, like a car that you wind up and that's mechanical. You have to wind it up, then it moves. So yes, that's what mechanical energy is. Number 3, it says during photosynthesis, again the word photosynthesis, food for plants, energy is stored, it's kept, it's saved, it's kept in the form of what? Well, we just said that it goes from light energy into chemical energy. So now we gotta find something that's chemical energy. Okay? Oxygen is a gas. Carbon dioxide is a gas. So these can't be your answers. Okay? Glucose, alright, is a chemical. It's in fruit, it's in vegetables, it's in the plant. And water is a liquid. And water is used in photosynthesis. So this one, I would say carbon dioxide is not only a gas, but it's going to be a reactant. It started the process. Water was also a reactant. Okay? And oxygen is a waste product. It exits. When you have waste or you have trash, you have to take it out. Well, the plant takes out the waste product. It doesn't need oxygen. So, it's crossed off. Carbon dioxide is a reactant. That's at the beginning. We don't need that. Glucose is a chemical. It stays in the plant. Some plants make fruit, or like carrots, they keep it in the roots. And then water is definitely not it. It's a reactant. It starts the process. So your best choice is letter C. Number 4, when energy is passing through a food web, some of the energy is lost as heat. Approximately how much of the energy is passed from one level to another. So if we have a from producers to primary consumers to secondary consumers to tertiary or to the apex predator every time we're jumping one, we have to subtract 90%. So the only thing that goes up is 10%. There's only a 10% amount of energy that switches over to the next level from the first level. So from this level, we got 10%. From this level, we take that 10%, and then we take a 10% out of that one. And then from that original, from this one right here, we get another 10%. So it's always just 10%. So your best choice is G. You lose. 90% is what you lose, or it's lost. Okay? So that is number 4. The answer is G. Number 5, the diagram below shows a desert food web. Alright, so let's take a look at that. Let's see if I can move this. How will a decrease in the number of rats impact the food web shown above? So a decrease, less. Okay, so if this number right here there's less of them. Let me see what's connected. Well, let's see if I can change this color. Alright. That's fine. Alright. Well, we have the cacti being connected, the sagebrush, the hawk, oh, not that one. The snake being connected, and the coyote. So all of these are going to be since they're connected to the rat, they are going to be impacted. Let's look at what the word impact means. It means that there's going to be a change. Okay, most of the time the word impact, it has a negative connotation. It means something negative. Okay, so when we have an asteroid impact a planet, that means that it hit, that it caused something, it dented it, caused a crater, or even it caused an explosion, it caused something else to happen. Okay, so it's a change, it's something that's different, an effect. Okay, so what effect is going to happen? A says there's going to be an increase in the number of ants, tarantulas, and snakes. Ants are right here. We didn't even talk about ants because they're not connected. The tarantulas are not connected directly to the rats, so we can't. These are not connected. So boom, A is out. There will be an increase in the number of snakes. Okay, are snakes connected? Yes. Are the coyotes connected? Yes. And the hawks. But that meant that these food sources right here, the snakes, the hawks, the coyotes, they lost a food source. So if this number is going down, okay, their numbers are also going to go down. So an increase is that there's more. Well, that's not so much the case. B cannot be your answer. Their numbers are going to be going down. There will be a decrease. There will be less of the number of snakes, coyotes, and hawks. That's a question mark because that seems like the best choice. That's just the opposite of what I just said wasn't. And letter D, there will be a decrease in the number of cacti. Let's see. Cacti and sagebrush. There will be a decrease. Well, if the rat's not eating the cacti, if the rats aren't eating the sagebrush, then there would be a increase because they don't have a predator anymore. So D cannot be your answer. C must be your answer because there's a decrease and for sure there's a snake, coyote, and owl connected to the rat. Number 6, what happens to solar energy? Energy from sun. What happens to solar energy absorbed? Taken. If you don't know what the word absorb is, it's taken in by plants during photosynthesis. For plants. So what happens to the energy from the sun when it's taken in by plants to make food for plants? So let's see. It is recycled by plants and returned to the atmosphere. So we haven't even talked about recycling. And plants don't do that. There's a process. Photosynthesis is a process, so something else comes out. There's reactants. There's things that go in. And then we get a product. When those reactants react, they make a product. Letter G says it is converted into oxygen and glucose. And oxygen and glucose are the products of photosynthesis. So that's your question mark. It is stored as heat within the plant? No. And Letter G, letter J says it is transformed into chemical energy. So chemical energy is half of the answer. Okay, but you only get half. You need both answers, which would be glucose and oxygen right there. Alright, so we are on number 7. It's the same diagram, but now it's asking us to find the producers. It says which organisms represent the producers. So we need plants. We need autotrophs. Okay? We need an organism that makes its own food. Well, we have cacti at the bottom. We have sagebrush. They don't have arrows coming into them. Okay? So, it's our first answer choice right there. Coyote is a consumer. The hawk is a consumer. The coyote, these are consumers. Same thing with this one, same thing with this one, same thing with this one, same thing with those. Right there. These are all consumers. So your best choice for number 7 is A. Number 8 says which type of energy conversion occurs during the process of photosynthesis. So food for plants. Conversion. The word conversion means it started off as something and ended up as something else. So conversion, or we can simply say change. So which type of energy change occurred during the process of photosynthesis? Well, chemical energy is converted into radiant energy. No, we do not make radiant energy. That just comes straight from the sun. Radiant energy, okay, that's a question mark so far, is converted into thermal energy. No, that's not what happens. Plants do not keep heat stored in there. Thermal energy means heat. Okay? Thermal energy, we already started off wrong, is converted into chemical energy. So no. Radiant energy from the sun is converted, is changed into chemical energy, into glucose. That's true. So J is your best answer choice. Number 9. We have this wonderful picture. Zoom out. Analyze the positions of the eagle and the snake in the food web picture above. Okay, so we're looking for the eagle. We're looking for the snake. Okay. Which of the following statements is correct? Alright, so they're going to have some statements. Here we go. The eagle eats more types of organisms in the food web than the snake. Let's see. So this is 1. This is 2. And this is 3. Alright, so he eats a total of 3. The snake has 1 and 2. That's it. So this statement is correct. So I'm going to put a question mark. I'm going to say it eats 3 and it eats 2. Okay? The eagle eats the same types of organism as the snake. Well, I can't say it's the same because this one eats 3, this one eats 2. The snake eats 2, the eagle eats 3. That's not the same. 3 is not the same as 2. So it's an obvious one that 3 is not the same as 2. So even if they both eat the mouse, because this is an animal that they both share, even though they both eat the mouse, okay, they don't eat the frog, or they don't both eat the rabbit, and the owl eats the snake. So this one is false. Okay? Letter C says the snake eats more types of organisms in the food web than the eagle, and we just proved this one. This one is the snake eats 2, the eagle eats 3, so no, the snake does not eat more. And then letter D says the snake is eaten by same types of organism as the eagle is. The eagle is not eaten by anybody. So the eagle is not eaten by anybody, so D is false as well. So this one's false, this one's false. So your best answer choice for number 9 is A. Number 10, same picture. Analyze the food web above. Which animal receives the most energy originally produced by the plants in the food web? So, the plants start off with 100% of energy, and it is the primary consumer. So this one, this one, this one, oh, not that one, excuse me. This one, oh, I guess I must have changed something, okay? The caterpillar. So we got 1, 2, 3, 4 organisms that will receive 10%. Okay? The frog's only going to receive from the 10%, he's only going to receive 1%. So no. The eagle is also going to receive 1% if it eats the rabbit. So no. The snake will receive 0.1%. So no. Caterpillar receives 10%, grasshopper receives 10%, and the rabbit receives 10% with the mouth. Right? So rabbit receives 10%, the frog receives 1%, the owl could receive 1% if it ate the rabbit, and the snake gets 0.1 because it eats the frog, and the frog ate a grasshopper or a caterpillar, and then they ate the shrub. So J, H, and G cannot be your answers. Your best choice is the rabbit because it receives 10%. Number 11. Oh, well now my computer's frozen. Alright, number 11. What do the arrows represent in the diagram of the food chain? So what do these stand for? What do they mean? Okay, that means they all mean the flow of energy. So you need to find something that says the flow of energy. The order of size, no. The importance, no. They're all important, especially the producers. The direction of energy flow through organisms, or the energy increasing as you move. This one's not it, this one's not it, this one's not it. See, it's the direction, the flow, the movement, okay? The movement of energy. Alright, so that's number 11. Number 12. A student diagrammed a food web of algae, snails, ducks, frogs, and snakes that she observed during a summer trip to her grandparents' farm. So we have the food web right here. The question is, what is the correct arrangement of the above organisms on a energy pyramid? So I circled this and put these are the producers. So I gotta make sure pyramids have the grass and the algae and the producers trophic level at the bottom. The next level would be the primary consumers. So we've got to make sure they're on the next level on top of the producers. And let's go ahead and look at our answer choices. So, the first one has the hawk at the bottom. The hawk is not a producer. So F is wrong. Let's scroll down and see if we can look at G. Oh, playing around with me. Letter G has grass and algae. Yes, so far. Let's look at what are the primary consumers. the cricket, the small fish, and the snail. The cricket, the small fish, and the snail. Yes. The next level has to have the duck, the large fish, and the snake as secondary consumers. So let's take a look at G. Large fish, duck, and hawk. The hawk is incorrect, so G is not our answer choice. H. Grass, algae, small fish, large fish, snail. This is incorrect. So H is not our answer. And J. The hawk is at the top, the grass and the algae is at the bottom, the small fish, the cricket, and the snail in the right place, the large fish, the snake, and the duck are at the right place. They match with the food web. So J is your answer choice. Number 13, this was the sentence I continue to repeat in class all the time. The more diverse, the more variety there is, then there is going to be more of something. More threatened populations? No. More similar the species will be? Well, variety and diverse do not mean similar. C means more sustainable. When you have variety, they sustain each other, they work together. So I'm going to put a question mark. There's fewer variety. I just said there's more variety. So D is not your answer. C is your best choice. Number 14. Which of the following statements best describes the flow of energy, the movement of energy, the direction of the energy in the energy pyramid above? So we know that if we draw our arrow, it has to go up. And we know that we always start with 100% down here, and we lose 90. So we're only passing 10% every time. F says, as you go higher in the pyramid, the amount of energy increases. That's not true. The second part's not true. There is less energy in the producer than there is the consumer. Well, actually, the producer has 100%. Everybody else has less than 100, so no. Letter H, there is no energy above the level of producers in the system. That's false. There is energy. And letter J says each group receives only a small amount of energy. That is correct. They only receive 10% from the level below. So J was your best choice. Number 15, tropical forests have the greatest biodiversity, so the greatest variety of life of any land ecosystem. So this is a fact. How does biodiversity contribute? The word contribute means how does it add to sustainability? How does it add to being able to survive? Okay, for the survival of an ecosystem. It says greater genetic variation, and we like that word variation, within species make it more likely that some individuals will survive a disease outbreak. Yeah, we like that. Letter B, the presence of more species with different adaptations make it more likely that some organisms will survive an ecological disaster. We like the word survive, like the word different adaptations, because that gives us variety. So A and B are good so far. The presence of a variety of herbivore species that can feed on a large number of different producers species help ensure abundant prey for predators in the ecosystem. So we have a variety of herbivore species, and there is a large number of different producer species giving you enough food. So we like all three answers so far. The reason why I'm checking them off is because I saw that it said all of the above at the bottom. So I've confirmed that A, B, and C are great choices, so D ends up being my answer. Number 16, which type of energy is formed during the process of photosynthesis. Every time we circle photosynthesis, we put food for plants. So what did it form? What did it make? The end result was chemical energy. Letter F. Radiant was to start. Thermal, there's nothing about thermal, there's nothing about kinetic that we've talked about. So F is your choice for number 16. Number 17, an ecosystem that is not, should have circled the word not, sustainable. Okay, so an ecosystem that's not sustainable can break down when a natural disaster occurs. This can lead to organisms in the ecosystem either leaving the area or dying off. So it's giving you a fact. Increased biodiversity, so more biodiversity, the word increase means more, results in a more sustainable ecosystem. So why is it that we have more sustainability when there's more biodiversity, there's more variety? Is it because there's a greater number of plant species? Well, it's not just plants. It's a greater variety, yeah, we like the word variety, of species present allows more organisms to adapt after the change. So I'm going to question mark this one because it sounds good. Letter C says there are fewer species to be affected. That's not true. Fewer and more do not make any sense. And letter D says the transition area between two ecosystems is narrower. And this one just confuses me because we're not talking about two ecosystems, we're talking about one. So A, C, and D are wrong. B is your best answer choice. Oh, my favorite. Number 18. It's asking you about the levels of organization. It says nesting dolls are a set of hollow wooden toys that have the same shape. Smaller nesting dolls fit inside larger dolls so that all smaller dolls fit into the largest doll when completely assembled. Students were asked to use the nesting dolls to model the levels of organization from largest to smallest. So you should have circled largest to smallest. Which model best demonstrates the levels of organization in plants and animals? So let's take a look. So if you remember, the largest is going to be your organism, and the smallest is going to be the cell. Well, I got to find one of the answer choices where the doll is the largest and it says organism. So F doesn't have that. This one's wrong. G says organism, so I'm going to question mark it. I'll come back and look at it. H says cell, so that's not it. And J has organism, so I'm down between G and J. They both have cell at the very end, so now I've got to take a look at the in-betweens. So after a cell, we have tissues. After a tissue, we have an organ. And after an organ, we have organ systems. Alright, so knowing that, we got to find if G or J is correct. Cell, tissue, tissue, organ, organ, organ system, organism is at the end. So G makes sense. J has these flipped around. So J is not your answer. Number 19, we practice in class, and the one we practice in class, we gave you the answer, so you should have known that it was the tundra because it has more biodiversity in the producers, so that is letter B. This one was one we gave you in class. And the last one we have is which of the following situations contributes, adds to the sustainability, the survival of an ecosystem. And this one we have biodiversity, so F is your answer. Decrease in biodiversity is not it. Extinction, the death of populations is not it. The removal, the takeout is not it. We have to, something that adds. Everything else, all the other answer choices, subtracted, took out. erased, demolished, killed. So that's not your answer. So your answer is F for that one. All right. Fill out your paperwork. Have it in by next Friday.